Hi there, Mr. Sutton here, bringing you the IM3 2-1 Extra Practice Number 2 solutions on operations with polynomials. To simplify in this one, we have to multiply these parentheses together. So we're going to have to distribute everything in the first parentheses to everything in the second. So we've got negative r times 7r. That's going to be negative 7r squared. And then negative r times 2, that's negative 2r. Next, we distribute the negative 7 to the second parentheses. So we have negative 7 times 7r, that's negative 49r. And then negative 7 times 2 gives us negative 14. Let's see what we can combine here. Looks like these r's in the middle can be combined. So we end up with negative 7r squared minus 51r minus 14. To simplify this one, we're going to FOIL or multiply these two parentheses together. So we have 6p times 8p, those are the first terms. We're going to have to multiply 6p by everything in that second parentheses. So that gives us 48p squared for our first term multiplying. And then we have 6p times negative 1, that's negative 6p. Now we have negative 6 distributed to the second parentheses. That's negative 6 times 8p giving us negative 48p. And then negative 6 times negative 1 is positive 6. So we have negative 6 and negative 48p. That adds up to negative 54p in the middle. And everything else is completely unchanged. To simplify these, we have to multiply the parentheses together. 7n and 7 both have to be distributed to 4n and negative 7. So we have 7n times 4n. That's going to be 28n squared. Now 7n times negative 7 gives us negative 49n. 7 times 4n is 28n. And then finally, 7 times negative 7 is negative 49. We can combine these n's in the middle because they have the same variable and exponent. Negative 49 and 28 adds up to negative 21. So we have 28n squared minus 21n minus the 49 at the end. Simplifying this next problem can be a little bit dicey if you're not careful. We have a negative out in front of everything. That's basically saying we have a negative 1 that's getting multiplied. Now, this negative 1 is only being multiplied by one of these parentheses, not both. Because once you've multiplied negative 1 by one of these, you've basically used it up. So I'm going to start by multiplying negative 1 by this first parentheses. That's going to give me a negative 7x plus 5, distributing a negative 1 in there. And now I'm going to multiply that new parentheses times this other remaining parentheses. So I'm going to have to do first outer, inner, last, FOIL, or basically just distribute each thing in the first parentheses to the whole second parentheses. So we've got negative 7x times negative 8x. That's 56x squared. Negative 7x times negative 6 is going to be 42x. 5 times negative 8x, that's going to be negative 40x. And 5 times negative 6 gives us negative 30. 42x minus 40x, that's going to be 2x in the middle. We still have the 56x squared and the negative 30 along for the ride, so we're done. For this problem, we need to multiply 3k plus 8 times this whole second parentheses. So I'm going to take kind of an optional step and split this up just to show what I'm doing really clearly. So I'm going to end up with 3k times that second parentheses plus 8 times the whole second parentheses. And now I'm just going to distribute this 3k and this 8 separately and combine like terms. So 3k times 7k squared, that's going to be 21k cubed. You're doing 1 plus 2 for the exponents there. 3k times 7k is just going to be 21k squared. 3k times 3 is plus 9k. Next we have 8 times 7k squared, that's plus 56k squared. And then 8 times 7k gives us plus 56k. Finally, we have 8 times 3, giving us 24. Combining like terms, it looks like 21k cubed is the only cubic term, so we'll just bring that down. 21k squared and 56k squared have the same exponent and variables, so those can be combined to give us 77k squared that we're adding in there. And then 9k and 56k can get added, that's 65k. And then the 24 just comes down because there's nothing to combine it with. For this problem, we have these two expressions here, 6x squared minus 7x plus 5 and all the rest of this, being written in ax squared plus bx plus c form, and they just want to know the value of a. So basically they're saying if you simplify this thing what's the coefficient of x squared going to be? That's what they're asking here. So you could simplify this whole thing and combine like terms and all the rest. But since they just want to know the value of a, the coefficient of x squared, you can kind of shortcut the process if you just keep track of the square terms. So if we were to distribute this -3, we would end up with a 6x squared from the first parentheses minus a 3x squared from the second. And of course, there's some other terms in there as well with x's and constants. But again, we're only interested in the x squared term because we just want the value of a. So at some point, the 6x squared and this -3x squared get combined, and they're going to give us a 3x squared. Again, there's a whole bunch of other terms that we would have to combine. But if we're just interested in a, the coefficient of x squared, that's just going to be this 3 that we see here. On this problem, they basically want us to simplify this expression here to get one of these answer choices. Since I've got just a parentheses plus another parentheses, if I wanted to, I could just rewrite all of this without the parentheses. So rather than just wasting a step, pretty much rewriting all of this, what I am going to do in my first step is put the like terms next to each other. So I have a -mn squared, and there's a positive 2mn squared over in this other parentheses. So at some point, those need to get added together. I have this plus 2n squared, and I'll have a minus 2n squared to go with it. And then finally, this -6m squared n and this 3m squared n can get put next to each other. So combining like terms here from left to right, these mn squared terms, you've basically got -1 plus 2, which is positive 1 mn squared. So I'll just write mn squared. I don't have to write the coefficient of 1 there. These n squared terms are complete opposites, so they're going to cancel out. And then over here, we have a -6 and a 3 m squared n, so that's going to be a -3 m squared n. Add the coefficients, keep the variables the same. So looking at my answer choices, it's looking like that's answer choice B. On this one, we have ax plus 3 times bx plus 5 equaling this expression here for all values of x. And they're also telling us that a plus b is 12. Based on this, they want two possible values for k. So what I'm going to do here, since I've got two different representations of the same thing, I'm actually going to multiply this left side out. My strategy here is I want to make the left side look like the right side of this equation. If I can do that, then whatever my coefficient of x is, that's going to be equivalent to this k that they've written over here on the right. So let me multiply out the left side by distributing, so basically foiling. First, outer, inner, last, or just distribute everything in the first parentheses to the second parentheses. So we have ax times bx, that's going to be ab x squared. And then ax times 5, that's 5ax. 3 times bx for those inner terms, that's going to be 3bx. And then 3 times 5 gives us that 15. So based off of this, I could actually, if I just wanted to get a single coefficient of x, what I could do is kind of undistribute an x from these two middle terms. So that would give me like a 5a plus 3b in a parentheses next to x. And this is totally legal. This is actually called factoring out a common factor. But you'll see this is legal. If you were to distribute this x back out, you would end up with 5ax plus 3bx. So these are equivalent. So we can draw a few conclusions based off of this. In order to get k, we need to know what 5a plus 3b is. Well, we know what a and b multiply to, because since this expression is equivalent to this 35x squared plus kx plus 15, that means that whatever is next to x squared has to have a value of 35. Well, that means that ab must have a value of 35. So we know that a and b are factors of 35, which is important because, again, in order to figure out k, you need to take 5a and add it to 3b. So you need a few values of a and b to work with. Okay, well, there's a few things that multiply to give us 35, actually a whole lot of things, if we're allowed to use decimals and things like that. 1 in 35 would work for just whole numbers, except that we have to look up here. They said that a plus b equals 12. So 1 in 35 can't be the value of a and b in this problem. Okay, well, what else multiplies to give us 35? How about 5 and 7? That adds up to 12. So I'm going to make a tiny little table here. Let's say that A is 5. That means B would have to be 7. Now they wanted to know K values. So what happens if I plug in 5 and 7 for A and B in this 5A plus 3B expression that we said was the same as K? We would have 5 times 5 plus 3 times 7. That would be 25 plus 21, which would be 46. And that's already one of the answer choices, choice A. But let's just go a little bit further. Now, another possibility here is that A is 7 and B is 5, right? Because that would still add up to 12 if I did A plus B. So that would be 5 times 7 plus 3 times 5. So 35 plus 15, which would add up to 50, which would also give us answer choice A. For this one, we need to figure out which expression down here is equivalent to this expression, which is to say we essentially need to simplify this expression, which is to say we need to multiply 2x, x minus y, and x plus 3 together. Now, the key to multiplying three things together is not to multiply three things together. It's to multiply two of them together, get an answer, and then multiply that by the third thing. So I'm just going to distribute this 2x to the x minus y parentheses. That's going to give me 2x squared minus 2xy. And I'll also have that x plus y parentheses that I haven't done anything with yet. But I'm about to do something. To multiply these two parentheses together now, I have to distribute everything in the first parentheses to the second parentheses. So we have 2x squared getting multiplied by x plus y. 2x squared times x is going to be 2x cubed. And then 2x squared times y, that's just 2x squared y, so nothing fancy there. Next, we have negative 2xy getting multiplied by the second parentheses. So multiplying that by the x gives us negative 2x squared y, which, yeah, that kind of looks familiar, doesn't it? We'll speak a little bit more to that in a minute. But now 2xy negative times y, that's going to be negative 2xy squared. So we can see here, combining like terms, that we have a 2x squared y and a negative 2x squared y. Same exponents, same variables, just basically opposite coefficients. So those are going to cancel out. So we really just end up with 2x cubed minus 2xy squared. And that looks to be answer choice C.